Evening. We're going to talk about the division algorithm, mod and div operations, and equivalence modulo. Let's start by giving a definition for the division algorithm. So the division algorithm, first of all, requires all integers. So A, B, Q, R, all are integers. So if I start with two numbers, A and B, division algorithm tells me that B is equal to Q times A plus R, where R has the special condition that it must be either positive or zero, and it must be less than the absolute value of A. So this division algorithm is the same thing you learned back in elementary school. If you did B divided by A, you got the answer Q with the remainder R. So it's that same division. All right, we are using all integers now, not just positive integers like we used back when we first learned division. But let's look at this first example. 30 equals something times 7 plus a remainder. What we know about this remainder is that it must be either 0 or greater than 0, and it must be less than 7. It's clearly not going to be zeros because 7 doesn't go into 30 evenly. 7 times 4 is 28. 7 times 5 is 35. So we're going to get 4. 4 times 7 is 28. Plus 2 more will get us up to 30. Notice the definition of these two operations, mod and div. B mod A is the remainder I get when I do B divided by A, and B div A is the quotient I get when I do the remainder. So looking over here, the remainder I got from 30 divided by 7 was 2, and the quotient I got was 4. So 30 mod 7 is equal to 2, and 30 div 7 is equal to 4. All right, let's try it with a negative number. So here I know that my R has to be between 0 and 3. It could be 0, but it's not because 3 does not go evenly. So I'm going to need a negative number here in order to get up to 28. So 28 is going to be 9 times 3 would be 27, and 10 times 3 would be 30. So I am going to be using negative 9 here, because negative 9 times negative 3 will give me 27 positive, and I can add 1. Notice there's only one answer to these because of this requirement of the R. So that means if I do 28 mod negative 3, I get the remainder, which is 1. And 28 div negative 3, I get negative 9, which is the quotient. All right, let's try it for the negative one down here. We're trying to get a negative number. So 8 times negative 5 would be negative 40. But remember, the R still has to be positive, or 0. In this case, it has to be positive. So if I were to put negative 5 here, I would get negative 40, and I'd need a negative 3. So I'm going to not be able to use negative 5. I'm going to use negative 6. So negative 6 times 8 is negative 48. And if I add 5 more, I will get up to negative 43. Remember, negative 48 is smaller than negative 43. So by adding 5, I will get up to that value. Negative 43 mod 8 is going to give me the remainder of 5. And negative 43 div 8 is going to give me a quotient of negative 6. All right, let's try one more example with all negatives, or both negatives, I should say, A and B. The R can't be negative, right? The R can be 0, but 3 doesn't go into 37 equally, so it won't be. It's got to be either 0, 1, or 2. Can't be 3. So it's got to be 0, 1, or 2. So again, negative 37. I'm going to need a negative product here, so that's going to need a positive number. And if I do, 3 times, negative 3 times 12, I'll get negative 36. And I'll need to go down one more. So that's not going to work. I'm going to need negative 13 here. Negative 13 will give me, oops, not negative. Better make that positive. Because positive 13 times negative 3 is negative 39. I add 2 to come up to negative 37. So I need a positive 13 here. And a positive 2 here, so the mod is going to be the remainder, and the div is going to be that positive 13. All right, so that's how we use the division algorithm, and that's how we define the operations mod and div. So now we want to define equivalence modulo. So it's not to be confused with the operation mod. So a definition of equivalence modulo is A is equivalent. These 3 little dots, 3 little equal signs mean equivalence. Not the same as equals. Equals are for numbers having the same amount. So if you've studied relations, then you know what equivalence means. It's very similar. Equals is an example of it. So I'm saying A is the same as B in some way. So A equivalent to B, how is it equivalent? By mod M, and that's only true if N divides B minus A. Now remember, N dividing B minus A means B minus A is equal to N times some number. Another way of saying it, more intuitive, is that A divided by N and B divided by N have the same remainder. So again, what we're saying is that A and B are equivalent somehow. How are they equivalent? How are they alike? They're alike in that if you divide them by N, you get the same remainder. That's how they are alike. So let's do some examples here. I have 10 mod 3. So if I divide 10 by 3, what kind of remainder am I going to get? Well, 10 divided by 3 is going to give me 3 remainder 1. So it's the 1 that we're focused on. What other numbers can you divide by 3 and you will get 1? Well, 7, right? Because 7 divided by 3 gives me what? 2 remainder 1. Well, are there any other numbers that you can divide by 3 and get a remainder of 1? Yeah, 4. So there's actually at least 2 answers. Of course, I could put 10 there too. 10 is going to have the same remainder as 10. But what about also 13? We could even go 1. Notice these numbers are all 3 apart. So I can start with 10, and I can add this 3 to get 13. 16 will work because that goes in there 15 and remainder 1, right? So 13, 16, 19. I can start with the 10 and subtract 3. 7, 4, 1. I can even go down to the negatives. So there's infinitely many answers that I can put here. Let's try the second one. 8 mod 5. So 8 is equal to something times 5 plus remainder. We'll do it the division algorithm way instead of the elementary way, school way there. So 5 goes in there 1 with a remainder of 3. So other numbers, notice we're not necessarily putting that here. We're just saying what other numbers are going to have the same remainder if they're divided by 5. So what about 13? So what if I divide 13 by 5? 5 goes into there 2 and gives me a remainder of 3. So 13 is an answer. What about 3 itself? So what if I take 3 and divide it by 5? Well, 5 doesn't go into 3, it's too small. So I get 0 and 3. So 3 is actually also an answer. Notice back in this one where the remainder was 1, 1 was an answer as well. So whatever the remainder is going to be one of those answers. Let's try 3 mod 7. So again, I'm going to do 3 equals something times 7 plus what? So I need to put a 0 here. And I will get a remainder of 3. So I am going to get I'm going to get 10 here, right? So 10 equals 1 times 7 plus 3. 3 0 times 7 plus 3. Right, so we have here 10 and of course 3. Are there other numbers that when we divide them by 7, we'd also get a remainder of 3? So I could do 3 plus 7 to get the 10. I could add another 7. So what about 17? 7 goes into 17 twice because 2 times 7 is 14. And the remainder is 3. So 17 would work. You can squeeze it in there. I could also do 3 minus 7 and get -4, -11, and so on. Okay, let's try this one. -7 equals something times 4 plus a remainder. So if I do -2 here, -2 times 4 is -8, and then I add 1 up to get that remainder of 1. So of course, -7 would give me a remainder of 4, or about 5. 1 times 4 is 4 plus 1, so 5 will work. Notice -7 plus 4 will work. Does that work? -3. Let's make sure I'm not feeling positive here. So if I put a -1, -1 times 4 is -4 plus 1 is 3. So as long as I put these 4 apart, I will get an answer that's equivalent. How are the numbers equivalent again? They're equivalent in that they have the same remainder. So let's notice with this last example here. For mod 1, I'm going to write all the answers that could fit down here, because 4 could fit. Mod 1 is going to go evenly. The remainder is going to be 0. So that's going to be 4, 5, 6, 7, 8, so on. Mod 2, what answers could I get? So obviously I could get 4, 6, 8, 10, and I could go down to 0, -2 in both directions. If I did for mod 3, I could get what? I could get, of course, 4, 7, 10, 13, keep going up. Subtract 3, 1, -2, -5, and keep going down. And for mod 4, of course, I could get 4, 8, 12. Notice these all have a remainder of what? They all have a remainder of 0. 0. Subtract 4. Subtract 4. So these all have a remainder of 0. Notice these all have a remainder of 1. These all have a remainder of 2. And I didn't go far enough for this one. All right, these all have a remainder of 3. So that is how we find equivalence modulo. And we can use prime numbers with that and do codings and stuff. Cipher kinds of codes. This is the division algorithm and the operations of mod and div.